How's it going? Um, originally this talk was titled Polyglot Microservices with a dash of Wittgenstein. It kind of turned into Wittgenstein with a dash of polyglot microservices. Um, Hopefully that's okay, and hopefully we can learn some stuff. So the first thing that Wittgenstein does in his philosophical investigations is introduce the concept of a language game. He does this with an example. A is building with building stones. There are blocks, pillars, slabs, and beams. B has to pass him the stones and to do so in the order in which A needs them. For this purpose, they make use of a language consisting of the words block, pillar, slab, and beam. A calls them out. B brings the stone which he has learnt to bring at such and such a call. Conceive of this as a complete primitive language. So this should actually all sound pretty familiar to everyone who has designed an API. This is kind of a mock request diagram of the interactions between A and B. And that question mark represents this internal process that B has to go through, sort of analogous to running to the database and fetching the data that A has asked for. I'm going to return to this slide a few times. And hopefully it becomes clear over the course of the talk what this slide is trying to do. Because I want to show how this language game, offers a useful way to look at microservice architectures by going through some practical examples from the projects that I've been working on. The broader point here is that we as software engineers are just starting to approach this problem that philosophers of language, like Wittgenstein, have dealt with for a long time. It's not so much that Wittgenstein or Frege or Russell or Quine or even Plato, if we're being a little flexible. Wittgenstein himself said that Plato's Theaetetus covered the same problems he was tackling. Actually solves all these questions that we're going to cover. Rather, these philosophers managed to ask the right questions, and they're the questions I think we should be asking. So here are the questions, some of the questions that I'm also not going to answer. One question that's going to come up is, how does data's meaning change from one context to another? How do we figure out what data means in a given context, and what do we do about it? It probably seems from these questions that I'm giving up before we even got started, but there are declarative corollaries to these questions which I hope I can leave you with in this talk. So data's meaning does change from context to context. We are able to describe data in a given context, and we have some tools to mitigate the confusion that can arise from data's meaning changing. So I guess I should introduce myself. I'm Chuck, an engineer at a small, currently 9-person startup called Assembly. We're based in San Francisco, and we're building a platform for people to collaborate and build stuff together. Right now, we're focusing on a social changelog that emphasizes transparency, and we're building it as a collection of microservices around a small Ruby on Rails Postgres core. My examples are going to mostly come from there. I should also note that although I'm going to be talking a lot about Wittgenstein, I'm not a philosopher. And it's entirely possible that I might get some of this stuff wrong. So let me know if that seems to be the case. We'll talk about it, and the only thing that's going to happen is we'll all be better programmers as a result of the discussion. So back to Wittgenstein. I actually lied previously. Introducing the concept of a language game is the second thing that Wittgenstein does in the PI. He actually begins with a lengthy quote from Augustine. I won't read it aloud to you. It's important to scan, though. The basic point is you have Augustine describing himself as a young boy and seeing adults especially pointing something out and saying like chair or like turning towards it and saying podium or lectern. And then he gets to learn to repeat these phrases. So the thing that's going on here is Wittgenstein is setting the stage to introduce language games. The adults pointing things out to the young Augustine are playing a sort of language game. And Wittgenstein also sets up his refutation of the picture theory of language. We can think of the picture theory as sort of analogous to duck typing in computer science. It's important to note here, though, that Wittgenstein was working well before computer science as we know it emerged as a field. He was, however, deeply familiar with the mathematical roots of type theory. He worked directly with Bertrand Russell. And here's a fun little bit of trivia to take from this talk. That we have pretty extensively recorded conversations between Wittgenstein and Alan Turing, because Turing took one of Wittgenstein's lectures. So in his first book, the Tractatus, Wittgenstein describes the picture theory of language as follows, with these propositions. And this is an important difference to note between the Tractatus and the philosophical investigations. In the Tractatus, you have 7 propositions that have a bunch of these sub-propositions, and Wittgenstein is very much going forth and saying, like, this is the case. He actually begins, the first proposition is the world is everything that is the case. In the PI, contrastingly, Wittgenstein sort of just asks questions and goes after things and says, oh, this looks really interesting, and then he kind of abandons it and moves on to something else. So it sets the stage here for his refutation of his earlier self. And what we're getting at here with these propositions is that if something looks like a duck, 2.12, walks like a duck and quacks like a duck, 2.13 to 1.4, we should call it a duck, 2.141. Like duck typing, the picture theory is helpful as far as it goes, but it proves limiting when we try to extend its use outside of a relatively small domain. So let's take a look at a practical example. This serializer comes from the Ruby on Rails backend for assembly social changelog. It claims to serialize a highlight, which is a distillation of something that happened on an external service. But since we're in Ruby land, there's nothing to say that what's been serialized is actually a highlight. As long as it responds to all of those attributes that we have listed, we'll just go ahead and call it a highlight. This practice raises obvious problems for microservice architectures, especially polyglot ones, and it's one of the reasons that choosing a data exchange format, as discussed in a bunch of talks so far, is so important. It gives us a way to interpret data consistently in every part of the application, but only if we follow certain rules. That is, only if we play a certain game. This problem concerned Wittgenstein 70-odd years ago. How do we account for the way meaning changes from one context to another? Put another way, how do an application's parts communicate with each other? And how will they communicate with each other next week? We've all had this experience looking at code. Someone suddenly sees something which he does not recognize. It may be a familiar object, but in an unusual position or lighting, and the lack of recognition perhaps lasts only a few seconds, but leaves open the possibility that it lasts quite a bit longer. This is why it's so important that we demand a better explanation than duck typing for Polyglot microservices. My Ruby service doesn't care what sort of time highlight.createdAt is, or even for that matter, that it's a kind of time. Ruby just cares that a given highlight responds to the method createdAt. So Wittgenstein illustrates this problem with a duck rabbit. If you look at the picture for a sec, you'll see how it earned that name. You might have to turn your head to the side slightly. But everybody got it, seeing both the duck and the rabbit? Cool. So Wittgenstein asks, is it correct to say that someone who fails to recognize an object has a different visual experience from someone who recognized it straight away? Couldn't someone describe an unfamiliar shape that appeared before him just as accurately as I, to whom it is familiar? And isn't that the answer? So Wittgenstein answers his question with a question, and that's sort of his point. It's not so much that we look at the duck rabbit or a highlight and say that it is a duck or a rabbit or one highlight or another. It's rather that we need to acknowledge the differences that emerge from looking at the object under different light in different contexts, and we need to build an application that is a language game that accounts for those differences in the way that it transmits data. In other words, when we're talking about microservices, it's less instructive to talk about duck typing, and perhaps slightly more indicative of the problem and its challenges if we talk about duck-rabbit typing. For example, we'd have a weird parsing issue on our hands if highlight.createdAt returned a string, which may or may not represent a datetime object in some crazy world. Highlight createdAt means different things in different contexts, and to preserve that meaning across contexts, we need to transmit the field in such a way that, that the receiving context doesn't need to ask what or how it got highlight createdAt. It just needs to spit out what it got. Oops, sorry. Microservices are all the rage because they supposedly encapsulate our problems better than monolith applications. But when we talk about microservices, we often wave our hands when we get to the clean interfaces part and pretend that well-tested, isolated components globbed together in a single application can magically produce a coherent product, as if a functioning application were an emergent property of pinning microservices side by side. This is obviously not the case. How we transmit our data is the glue that holds our application together. And I suppose what I'm after here is a series of rules, albeit an abstract, language-agnostic series of rules, for communicating between services. The trouble, it turns out, and if you get nothing else from this talk, remember this point, is that we're dealing with context-dependent meaning we're dealing with context-dependent meaning in the midst of context-independent appearance. What a service says depends on how the service says it, even if the data itself appears the same from one service to the next. Nevertheless, by preserving the appearance of the data, or at least following discernible rules for its manipulation and transformation, we can avoid muddling about in data parsing hell. What we need to focus on is what the data is, or is not what the data is, or what it means in a particular environment, but how it travels along our application's pipeline. Here's an example from one of the reporters that constructs highlights. This one works on Slack messages. This particular reporter implements a leaky bucket that overflows if a conversation in a Slack channel starts to pick up, and then parses the messages still in the bucket, tries to figure out the one that kicked the conversation off, and sends a highlight to the core service about it. Note, importantly here, that the data transformations follow specific rules, and the Slack messages remain Slack messages. It's as if they just came from Slack. We just handled this, crazy thing. This isn't great closure, but it demonstrates the purpose of performing this transformation. We don't change the data that actually matters. We just hand it off and let each microservice do with it what it wants to. And this is a principle that we've applied with a lot of success in our front end application. So this is a related example. To start with, I'm going to walk through our modifications of Dan Abramov's Connect to Stores decorator. We modified it very slightly. If you're not familiar with React, or especially with ES6 7 2015, this might look like a lot of JavaScript-y gibberish. So just to briefly walk through it, what we've got here is a function that takes a few stores. It then accepts a component as its target and wraps it in this store connection thing that handles all of the state. In React, you change state only by calls to a component's this.setState, and you can pass a component props that you just aren't allowed to change under any circumstances except by a component higher up in the hierarchy. So what this does is it imposes that restriction on all the components that it renders. They should only receive props and not really be manipulating their state. All the state manipulation happens here when stores emit their changes. So moving state management out of the component keeps the components really dumb. They just receive props and render what's there. So here's a really simple example of that decorator in use. What we want to check is that we have a username that's available. So all that this component does is renders the username that you've typed into the input and whether or not it's available. It doesn't actually perform any of the validation itself. It has one little check to say, oh, is there an error that I need to render, because we want to apply some styling to it. And then it just spits out this as it appears on the page. So in other words, this component just plays the game that its context plays, which plays the game that its context plays, and all the way back to the database that says either that username is taken or that username is available. To get back to a slightly more involved example with the highlights, you can see that we're doing the same thing here. I've cut out some boilerplate, but basically we get a list of highlights in, and then we just spit them out on the page. We style them as much as we want, but we're not changing the way the data is presented. So we get back to our builders, A and B, where we have A, the client side of our application, talking to B, which we can think of as the server, who goes and retrieves this data. So we can make the obvious point here that A's internal processes that prompt him to call out block or slab have little bearing on B's internal processes that help him match A's command with the requested material. But we can go past this and note that what helps B to correctly match A's request is exactly those internal processes that B hides from A, and vice versa. In other words, we want B to take A's utterance as directly as possible, and for A to take B's utterance as directly as possible. We want to eliminate if branches in state, recognizing, for example, that the question, is A waiting for B, is of little importance to successfully completing the task at hand. This makes programming an interaction between two microservices, or a microservice and the main service, a lot like what we do when we talk. To quote Wittgenstein again, he argues that we're really just setting up a comparison. The language games here stand as objects of comparison which, through similarities and dissimilarities, are meant to throw light on features of our language. For we can avoid unfairness or vacuity in our assertions only by presenting the model as what it is, as an object of comparison, as a sort of yardstick, not as a preconception to which reality must correspond, the dogmatism into which we fall so easily when doing philosophy. A compares his or her assertion to the result produced by B. B compares his or her material, slab, block, etc., to the assertion produced by A. We aren't building these microservices for each other. A does not exist for B, but rather they both exist to produce some output together. We're building these microservices for other people, be they co-developers or end users, and we can make them easier to understand by orienting them around their data and how they pass it around, rather than around the fancy transformations that each service performs in the data that comes into it. That's not to say that fancy transformations have no place in microservices. Obviously, we need this, but it's, and B here certainly performs some fancy pattern matching when deciding whether to pick up a block or a slab. It is to say, rather, that the transformation's output must play by the rules of the broader language game. This point actually stands in favor of polyglot architectures, albeit in a somewhat counterintuitive way. By using the tool that performs the transformation most discreetly, but that interfaces most cleanly with the other parts of the service, we preserve the integrity of interactions among services. We avoid unfairness or vacuity in our assertions by presenting the model as what it is, an object of comparison. So to sum up, polyglot microservices help us focus not on what our data means, but on how it's conveyed. What our data means ultimately disappears when we use the right language to manipulate it, because it changes based on context anyway. And what's left is how we tell other services and our users about the data. We accomplish this by displaying the data, sometimes literally, as it comes without attaching our own state to it. I'll end with one last bit of Wittgenstein. Can there be a clash between the picture, our data, and the application? Well, they can clash insofar as the picture makes us expect a different use, because people in general apply this picture like this. I want to say here we have a normal case and abnormal cases. That's all I've got. So quick further reading. Time for questions if there are any. I know everybody's probably eager to get to lunch. So thanks.
Is it worth trying to have a single notion of meaning throughout an entire application, or should we just resign ourselves to multiple meanings?
Not to be fatalistic about it, but I think we need to resign ourselves to multiple meanings. One of the Wittgensteinian mantras that I sort of purposely tried to avoid because it opens up an entire can of worms is this notion that meaning is use. This is one of the big changes that happens between the Tractatus and the PI, where Wittgenstein is like, oh, meaning is what's represented, and then he draws the duck rabbit in the PI, and he's like, actually, meaning is just the context in which something appears. So I think we always sort of need to recognize that the data are going to mean different things in different contexts. I actually originally had an example from one of our Golang microservices, which is obviously statically typed, and so if it says it's a message, like for the purposes of that microservice, it's a message with the object that we were dealing with. But when you pass that message around, there's nothing to say what it is in another context, and that's just kind of to underscore this whole what your data is saying changes from context to context and how it's said.